We need to simplify the given expression. So let's begin by first stating the De Moivre's theorem, which states that whenever we have cosine of theta plus iota times sine theta whole raised to the power of n, this is equivalent to cosine of n theta plus iota times sine of n theta. Now this can be also written in a compact form as cis of theta raised to the power of n, where the C will stand for cosine, I for iota, and S for sine. So this is equivalent to cis of n theta. So let's use the De Moivre's theorem. We will begin by considering each of the expression. We will start with the numerator part first. So in the numerator we have cosine of 5 theta minus iota times sine of 5 theta whole raised to the power of 7. First, what we'll have to do, we'll have to take care of this negative sign. We will use the fact that cosine of negative theta, that's equals to positive cosine theta, and sine of negative theta, that's equals to negative sine theta. This is true because cosine is an even function and our sine is an odd function. Right. So that means our expression will now become cosine of negative 5 theta plus iota times sine of negative 5 theta. So this will be raised to the power of positive 7, which will be equals to the cosine of negative 5 theta. So if we use the De Moivre's theorem, this will be simply equals to cis of negative 5 theta. So we're writing it in a compact form, raised to the power of 7, which is equals to cis of positive theta. This will be now raised to the power of negative 5 whole raised to the power of 7, which is simply equals to cis of theta raised to the power of negative 5 times 7, that will be negative 35. With this, we have simplified our first expression. Now similarly, we can simplify our other expression as well. So we have cosine of 7 theta plus iota times sine of 7 theta whole raised to the power of negative 3. So this should give us cis of theta whole raised to the power of negative 21. So you can check it out by using the same steps that we used in the previous one. And then we have cosine of 4 theta minus iota times sine of 4 theta whole raised to the power of 9. So this will be equals to cis of theta whole raised to the power of, so we'll have negative 4 multiplied to 9, that will be negative 36. Right. And then for this particular expression, we have cosine of theta plus iota times sine theta whole raised to the power of 5. So this is simply equals to cis of theta raised to the power of 5. So now that you have all of the 4 expressions written in this simplified form, we'll replace this value into our original expression such that we now have cis of negative 35 multiplied to cis of negative 21 divided by cis of negative 36 multiplied to cis of these are all theta, cis of theta whole raised to the power of negative positive 5. Now we'll combine them. So we have cis of theta whole raised to the power of negative 35 minus 21. So negative 36 will become positive 36 and positive 5 will become negative 5, which will be equals to cis of theta whole raised to the power of, so we have negative 5 added to negative positive 36, so this will give us a value positive 1. Then we have negative 1 minus negative 21, so that's negative 20. So negative 20 minus 5, this is going to give us negative 25. So our expression will then become cis of theta raised to the power of negative 25, or simply equals to cis of negative 25 theta. And if we expand it, this is going to be cosine of negative 25 theta plus iota times sine of negative 25 theta. And we know that cosine is our even function, so we will have positive cosine of 25 theta, and sine being an odd function, we have negative iota times sine of 25 theta. So this is going to be our simplified form of the given expression.